Four-engine commercial aircraft, like the legendary Boeing 747 and the Super Jumbo Airbus A380, have largely disappeared from mainstream passenger service, replaced by far more fuel-efficient twin-engine. At first glance, it seems the era of the Quadjet is finished for good. Yet aviation has a history of reinvention, and there are still realistic scenarios where demand for four-engine aircraft could return, even if only in specialized and carefully defined roles rather than widespread commercial dominance. One major factor is airport congestion. The world's busiest hubs continue to struggle with limited runway capacity and restricted takeoff and landing slots. When airlines are unable to add additional frequencies, the only practical way to transport more passengers is to increase aircraft size. High-capacity quadjets excel in this environment, on dense trunk routes between global where 500 or more travelers may fill a single departure. Very large aircraft can move enormous volumes of people in one slot. In such cases, the economics shift away from frequency and toward capacity concentration, a space where four-engine aircraft historically performed well. Cargo is another powerful driver. The demand for heavy and oversized freight is not only resilient, but expanding. Growth in e-commerce, large-scale infrastructure projects, renewable energy installations, and humanitarian operations has increased the need for aircraft capable of lifting exceptionally heavy or awkwardly shaped loads. Continued interest in the Boeing 747-8F and even legacy platforms like the Antonov AN-124 demonstrates how valuable four engines can be when operating at very high weights, from hot and high airports or on shorter runways. As global supply chains evolve and specialized shipments such as wind, turbine, blades, aerospace components, or emergency relief equipment become more common, operators may continue to see a business case for advanced multi-engine freighter concepts. Ultra-long-haul flying also keeps the conversation alive. Modern twinjets, such as the Boeing 777 and the Airbus A350, are certified for extended operations far from diversion airports thanks to rigorous ETOPS standards. Even so, extremely long polar or oceanic routes still involve complex planning considerations. Quadjets are not bound by twin-engine diversion time limitations, allowing greater routing flexibility across remote regions. While today's twins are extraordinarily reliable, four engines inherently provide additional redundancy. After a single-engine failure, a quad retains a greater percentage of total thrust and onboard power generation capacity. For certain government, military, or high-priority missions, that redundancy can still be attractive. The decline of quadjets, however, was driven by compelling economics. For nearly half a century, the 747 symbolized long-haul travel, reshaping global connectivity, but advances in high-thrust bypass turbofan technology allowed twin-engine aircraft to transport 300 to 400 passengers efficiently between almost any two cities worldwide. When the stretched and modernized Boeing 747-8 entered service in the late 2000s, it featured improved aerodynamics and next-generation engines. Despite these enhancements, market demand had already shifted. Production ultimately concluded in the early 2020s, marking the end of an iconic chapter that began in 1969. The A380 followed a similar trajectory, designed around the expectation that hub-to-hub traffic would overwhelm airport infrastructure. It could carry close to 600 passengers in typical configurations, while using the same runway footprint as smaller wide-bodies. However, aircraft like the Boeing 777-300ER and later the Airbus A350-1000 delivered lower seat-mile costs with far greater scheduling flexibility. Outside of its largest customer base, new orders slowed dramatically, and production eventually ceased. The earlier Airbus A340 had already experienced a comparable decline as rising fuel prices exposed the efficiency penalties of operating for medium-sized engines instead of two larger, more advanced ones. Still, four-engine aircraft possess technical strengths that twinjets cannot entirely replicate. Distributing thrust across four power plants allows designers to scale total output without pushing individual engine diameters or operating temperatures to extreme levels. This can support better takeoff performance at challenging airports and facilitate exceptionally heavy payloads. On aircraft, such as the 747, the placement of outboard engines even contributes structurally by reducing wing bending loads. Furthermore, Quadjets offer deeper systems redundancy, hydraulics, electrical generation, and bleed air features valued in specialized missions. The 747 family illustrates these advantages clearly. Unique design elements, including its nose cargo door on freighter variants, enable loading of outsized equipment that cannot fit through conventional side doors. Some operators have even transported spare engines mounted externally for repositioning because of its combination of speed, range, payload capability, and onboard power generation. The aircraft remains relevant for government transport, military logistics, and industrial heavy-lift roles long after its passenger dominance ended. Meanwhile, the A380 continues to find a niche with its most dedicated operator, Emirates. The airline's hub-and-spoke model enables it to consolidate. Massive passenger flows through a single global hub, filling hundreds of seats per departure, including large premium cabins. Discussions about potential upgrades, sometimes referred to informally as an A380 Neo concept, underscore that, under the right network conditions, very large aircraft can still align with an airline's strategy. Even if such developments remain unlikely, the conversation itself reveals that the Quadjet formula is not entirely obsolete. Interestingly, 4 engines are also reappearing in a completely different context. Boom Supersonic is developing the Boom Overture, a next-generation supersonic airliner concept that uses 4 engines optimized for efficiency and reduced noise. Unlike the historic Concorde, the design aims to cruise supersonically without afterburn, leveraging modern materials and aerodynamic refinement. Although it targets a niche premium market rather than mass transport, it demonstrates that 4 engines can still offer practical solutions for specific aerodynamic and performance challenges. Overall, the global aviation industry remains firmly oriented toward high-bypass twinjets for mainstream passenger operations. Their superior fuel efficiency, lower maintenance requirements, and flexible deployment models make them the clear choice for most airlines. However, infrastructure bottlenecks at major airports, expanding demand for heavy and oversized cargo, ultra-long-haul operational considerations, and emerging aerospace concepts may preserve limited but meaningful roles for 4-engine aircraft in the decades ahead, rather than a full revival of the Quadjet era. Any resurgence would likely focus on specialized applications, high-density trunk routes, extreme heavy-lift cargo missions, remote or strategic government operations, or advanced supersonic platforms. The age of 4 engines dominating global passenger fleets may have passed, but their story is not entirely finished. In aviation, as history repeatedly shows, technology rarely disappears completely. It evolves, adapts, and sometimes returns in unexpected ways.